Today we're going to be talking about parallel and perpendicular lines for the first day. So just to remind you, parallel lines are two lines in the same plane that never intersect. So they'll go on forever and ever, but they'll never cross each other. What that means about their equations is that they have the same slope, but different y-intercepts. Okay? So here's an example of two parallel lines. Again, they would keep going on forever and ever and never crossing each other. All right. So the first type of question we're going to look at says find the slope of a line parallel to the graph of the given equation. So all we have to do is look at the equation given to us, figure out what the slope is, and then say that what the slope of the line that's parallel to that would be. So again, it's really important to know that we have the same slope if we're parallel. So when we have y equals negative 4/5 x plus 7, remember that our slope, we use the letter m for slope, and so this is y equals mx plus b. So if we have negative 4/5 as our slope for the line given to us, then that means that our parallel line would also have a slope of negative 4/5. Over here, if we have negative 3x plus 4y equals 12, we don't have y by itself, so we can't just figure out what m is right away. We have to do some work. So we have to get y by itself. To do that, we need to move the x's. So that would leave us with 4y equals, these are not like terms, so remember we're trying to get it in y equals mx plus b form, so we're going to put 4y equals 3x plus 12. Then the next step to get y by itself is to divide every single piece by that 4, and we're going to simplify as much as possible. So 3/4 doesn't simplify, so we'll leave it as 3/4, and 12 divided by 4 is 3. So now that we have this equation in y equals mx plus b form, we can pick out that the slope, is 3/4, and since the lines are parallel, it has the same slope, and you just let it go. All right, next type of question here for parallel lines says write an equation for the line that is parallel to the given line and that passes through the given point. Okay, so we know that we're parallel to the line y equals negative 3/5 x minus 4. That means that our slope is negative 3/5. So we need to use this information. And we also need to use the 0.51. So this goes back to how we used point slope form last week. So we're going to plug this information in. We have y minus 1, because we're going to take the opposite of this number, equals our slope times x minus 5, since we're also changing that number. And remember, then there's two steps to take here. The first one is distributed. So we have y minus 1 equals negative 3/5 x, and negative 3/5 times negative 5. So if we do that work, I'll actually do it over here. Negative 3/5 times negative 5. Remember, that's over 1. So a negative times a negative is a positive. And the 5's actually go away because 5 divided by 5 is 1. So we would just be left with 3. Okay? To get y by itself, we're going to add 1 to both sides. So y is going to equal negative 3/5 x plus 4. Whoops. And that is our final answer. Okay? So we would want to make sure here our original slope was negative 3/5. Our ending is negative 3/5 as well, and they do have different y-intercepts. Okay? So let's try one more of those. So we have y equals 3x plus 9, and we know that we want to be parallel to that, and that this point we go through is 2, negative 6. So here our slope is 3, so we need that information, and we need 2, negative 6, the point, to plug in. So we have y, now since our y value is a negative 6, we're going to say plus 6, equals our slope, which was 3, since we're parallel, we keep it the same, times x minus 2. We're going to distribute, so 3 times x is 3x, 3 times negative 2 is negative 6. And then our last step is to get y by itself. So we're going to do the inverse operation. So instead of adding 6, we're going to subtract 6 from both sides. And we get y equals negative 3x minus 12, because negative 6 minus 6 is a negative 12. So that is our final answer there. Okay, so that's dealing with parallel lines. Those are ones that have the same slope and they never intersect each other. So then our other type are perpendicular lines. Okay, and perpendicular lines are two lines in the same plane that intersect to form right angles. So they're going to cross at 90-degree angles. That means that their slopes are opposite reciprocals. We're going to talk about what that means in just a minute. Okay, so here's an example of perpendicular lines. You notice that there is that right angle symbol in there. That's how we're going to prove or know, looking just at the picture, that they are right angles. Okay, that they're perpendicular. So here we're going to find the slope of a line perpendicular to the graph with a given equation. So perpendicular, okay? That means that we're going to have opposite reciprocal. Opposite reciprocal. So if we have y equals negative 5/7 x, okay? So the slope of this is negative 5/7. So the opposite means that we switch the sign of it, okay? And reciprocal means we flip the fraction. So we can even add that up here. So opposite means switch the sign, and reciprocal means flip the fraction. So if we do both of those things, it's negative, so now that it means our new slope is going to be positive. And if we flip the fraction, so we're flipping the 5/7, we would get 7/5. So positive 7/5 is our perpendicular slope to that equation. Okay, that's our answer. Here we have y equals 4x plus 3. So the slope of this is 4. It also might be beneficial to put in that over 1 piece, because when we flip it, we're going to get 1/4, so that's reciprocal. And then opposite means we're going to change the sign to be negative. So negative 1/4 is the slope of that reciprocal line. Okay. All right, so next we're going to write an equation for the line that is perpendicular to the given line and that passes through the given point. So same way we did with the parallel lines this time we're going to do perpendicular. So that means that we actually have to switch, we have to figure out that slope first, okay? So here our slope is 5/1 because y is already by itself. And so when we flip that and change the sign of it, our slope is negative 1/5. And then we also need this point, okay? So plugging in y plus 2 equals our slope. Now, when we have this part, and we have x minus 0, did we really need to write that part down? So no, you could have left off the parentheses. It doesn't really matter, okay? If it helps you to kind of keep following the same process, that's fine. So negative 1/5 times x is negative 1/5 x, and negative 1/5 times negative 0, or just times 0, is 0. So you could have skipped this line and just done this one because you notice that that 0 is not going to be necessary here. Okay, that doesn't mean we're done though. We got to get y by itself first, so we're going to subtract 2 from both sides. And that leaves us with y equals negative 1/5 x minus 2, since those two things are not like terms. So that's our final answer there. So let's practice one more of those. We're given the equation y equals negative 3/4 x plus 1 and the point 3,8. And we're going to go through the steps for this. So again, our slope right here, right now, is negative 3/4. That means when we flip it, we're going to get 4/3, and it was negative, so I'm going to make my slope be positive this time. So there's our slope. Here's our point. Plugging in, we get y minus 8 equals 4/3 times x minus 3. So when we distribute, 4/3 times x is 4/3 x. 4/3 times -3 is going to be a -4. So there I did 4/3 times 3/1. The 3 divided by 3 goes away, so we're left with just 4/1 or 4. Okay. And then we're going to add 8 to both sides to get y equals 4/3 x plus 4 as our final answer. So parallel lines are the same slope. Perpendicular lines have opposite reciprocal slopes. And that's it.